In today's lesson, you will review linear relations, be introduced to a particular type of nonlinear relation called quadratic relation, identify quadratic relation, function, compare both linear and nonlinear relations using graphs, table of values, and equation. What is relation? Relation is a rule for pairing numbers together. Many relations and patterns you have seen in the previous math studies were linear relations. Some relations are functions, but not all of them. You will explore this topic in more detail in grade 11. Let's look at the first example. A therapy dog program at a local school charges a flat fee of $1 and an additional $2 per hour to rent a therapy dog. To write a linear equation to calculate the cost in terms of the number of hours spent with a therapy dog, we were going to use two variables, x and y. X will represent the number of hours spent with a therapy dog, and y will represent the cost. So the equation will be y is equal 2x plus 1. It's of course written in a slope and y-intercept form. 1 is the y-intercept, 2 is the slope, 1 represents the initial value, a flat fee of $1, and 2 represents the rate of change, which is $2. Please also notice that the y-coordinate is of the first degree and x-coordinate is of the first degree. What I mean by that x has a power of 1 and y has a power of 1, which means both of those variables are of first degree. And that would be one way to recognize that you have a linear function. In order to graph this equation, we will now complete a table of values. You understand that each of the ordered pairs in the table of values represents a point on the line with the given equation. So let's do it. So our equation is y equal 2x plus 1. Now we choose x coordinates, x values. They are all positives because hours cannot be represented by a negative value. So now we're going to substitute those x's into our equation. 2 times 0 plus 1 is going to give me 1. 2 times 1 plus 1 is going to give me 3. 2 times 2 plus 1 is going to give me 5. 2 times 3 plus 1 is 7. And 2 times 4 plus 1 is equal to 9. So I have calculated the y-coordinates of my points. All right, so now I'm going to look at something called first difference. Well, first difference are the differences between the consecutive y values in a table of values. So let's calculate them. The difference between 3 and 1 is 2. The difference between 5 and 3 is also 2. 7, 5 is 2. And 9 and 7 is 2. So what you notice that those first differences are constant. The first differences can be only used to identify a linear relation if the x values in the table are increasing or decreasing by a constant value. So we're going to check those differences or changes in x values. The difference between 1 and 0 is 1. The difference between 2 and 1 is 1. 3 and 2 is 1. And 4 and 3 is 1. So they are constant. So therefore, I can conclude that this table represents a linear function because the first differences are constant. Let's quickly review slope. Slope is, of course, a change in y values over a change in x values, which is delta y over delta x, We know that our first differences are 2. The change in x values is 1, so therefore the slope is 2, and it matches the slope that was written in the equation. Now we're going to graph this function. Well, we're going to use our table of values, and of course we're going to use all the points from the table of values, and the points were 0, 1, 1, 3, 2, 5, 3, 7, and 4, 9. Okay, and now we will connect these points together, and we see that the graph is a straight line, which means the linear function is a function that can be graphically represented by a straight line. We also can recognize that there's a y-intercept. The slope is rise over run, and it's 2 over 1. So everything seems to be matching perfectly. If you were asked to calculate or to state the cost of 5-hour session with a therapy dog, you will use a graph to extrapolate and get the answer. But if we extrapolate this graph, we see that we ran out of room, we ran out of grid, and therefore solving this graphically has its limitations. So another way, of course, is to calculate it algebraically. You will start with your equation, y is equal to 2x plus 1. You will substitute 5 for x, and the answer will be 11. So the cost is $11. So, okay, let's look at another example to identify if it's a linear function. Well, the equation is x minus y equals 6. I will rearrange this equation for myself and isolate it for y. So y will be equal x minus 6. I will choose x values and then plug them into my equation. So 0 minus 6 is negative 6. 1 minus 6 is going to give me negative 5. 2 minus 6 is negative 4. 3 minus 6 gives me negative 3. And 4 minus 6 will be negative 2. I am going to check for the first differences. So, negative 5 minus negative 6 is going to give me 1. Negative 4 minus negative 5 is going to give me 1. Negative 3 minus negative 4 is also 1. And negative 2 minus negative 3 is also 1. All right, we'll quickly check the changes in x values. It's 1, 1, 1, and 1. So therefore, when I look at my equation, I see that both of my variables are first degree. Then when I look at my table, I see that the first differences are 1. And then when I graph this graph, my first point is 0, negative 6, 1, negative 5, 2, negative 4, 3, negative 3, 4, negative 2. And when I connect these points together, I will obtain a straight line. Therefore, this example represents a linear function. In conclusion, a linear function can be identified by equation. Both variables will be first degree. By a graph, a linear function is a function that can be graphically represented by a straight line. And by table of values, in a table of values, first differences will be constant. Now, let's look at the relationship between the area of a square and its side. To write an equation to calculate the area, the square area, in terms of a side length, we will use two variables, x and y. Y will represent the square area, and x will represent the side length. And the equation will be y is equal to x squared. Since square has two equal sides, and area of a square is side times side. All right. In order to plot this function, we're going to use a table of values. Our equation was y equal x squared. We've selected some values for side length. They're all positives because the side cannot be negative. And then we will substitute them into equation to calculate the area. So 0 to the power of 2 is 0. 1 to the power of 2 is 1. 2 to the power of 2 is 4. 3 to the power of 2 is 9. And 4 squared is 16. All right, now we're going to check for the first differences. We'll check the difference between 0 and 1, which is 1. 4 and 1 would be 3. The difference between 9 and 4 is 5. And the difference between 16 and 9 is 7. What we notice is that the first differences are not constant. So at this point, we can conclude that this table of values does not represent a linear function. Very quickly, we'll check the changes. The next values, they are constant. So then what we're going to do is calculate second differences, which means the differences in first differences. So what's the difference between 3 and 1? It's 2. The difference between 5 and 3 is 2. And the difference between 7 and 5 is also 2. So what we can notice is that the second differences are constant. And that would be our way, one of the ways to identify quadratic function. Okay, let's graph those points. So we had 0, 0, 1, 1, 2, 4, 3, 9, 4 and 16. We kind of run out of room. It's going to be somewhere there. All right, so let's join these points. And what I see is that the graph that is being produced here is not a straight line. It's actually a curve. So this illustrates that area is a graphing function of side length. In other words, there is a quadratic relation between area of a square and its side length. So what will be the area of a square with a side length of 5? Well, you can look at our graph and try to extrapolate. Of course, this graph will continue, but we have run out of room, out of grid, and therefore we cannot read from this grid. So therefore, we'll calculate it algebraically. We'll use our equation, y is equal x squared. The side length was 5, so it's going to be 5 squared, and the answer will be 25. So the area is 25 meter square. Let's look at a function with equation y equal x squared, but this time we will not define what x and y variable represent. Therefore, we will be able to use negative values for x coordinate. So once again, let's fill this table. So it's going to be -3 square, which is 9. -2 square gives me 4. -1 square is 1. 0 square is 0. 1 square gives me 1. 2 square gives me 4. And 3 square is 9. If I look at the equation, y equal x squared, I see two variables. Y variable, which is the dependent variable, and x variable, which is the independent. And what I notice is that the independent variable is of a second degree and the dependent variable is of the first degree. That would be one method to recognize a quadratic function based on the equation. All right, another way to recognize a quadratic function is by checking second differences. So first we need to calculate the first differences. So that's going to be the difference between 4 and 9 is -5. Between 1 and 4 will be -3. Between 0 and 1 will be -1. Between 1 and 0 will be 1. 4 and 1 is 3. And 9 and 4 is 5. So first differences are not constant. This is definitely not a linear function. Well, we'll check for the second differences. The difference between -3 and -5 is 2. -1 and -3 is also 2. The difference between 1 and -1 is 2. 3 and 1 is 2. And 5 and 3 is 2. So the first differences are constant and they are positive. Therefore, I can conclude that this table values represents a quadratic function. Let's quickly now graph it. Okay, so the points that I got in the table values were 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9. All right, and when I connect them together, I'm getting a curve. Okay, it's a very symmetrical curve. I will put arrows at the end of it because it could continue in that direction. I can tell that this curve will have no maximum value. It can keep going, but has a minimum value for the y coordinate. Y value is 0, cannot go any further down. All right, so this symmetrical curve is called a parabola. A parabola is a symmetrical curve that can describe the path of a projectile, like throwing a football, or the curve of a suspension bridge. It can also be used to represent the curvature of a banana. In conclusion, a quadratic function can be identified by equation. The independent variable is second degree, but the dependent variable is first degree. By graph, a quadratic function is a function that can be graphically represented by a parabola, and by the table values. In a table of values, a quadratic relation has a constant second difference. Also, when the second differences are positive, the parabola opens up, and when the second differences are negative, the parabola opens down. We will discuss special features of a parabola in the next lesson. The parabola is the only quadratic function we will study.